Understanding the logic behind the difference of two squares and how you can go about decoding them in an arithmetic or algebraic equations and expression will definitely increase and influence your speed positively in the field of mathematics. That is exactly what you're looking for. So in this channel, I'm going to walk you through the process one step at a time, and you will not want to skip any part of this video. Now, these questions we are about to solve, they are all GCSE maths questions. GCSE maths questions. I got them from thirdlearningspace.com. thirdlearningspace.com. So with you staying with us, I'm going to walk you through 8 questions on this GCSE mathematics. Thank you for staying with us. If you're new to this channel, really want to appreciate you. This is Obasimati tutorial. So without wasting much of your time, let us go to the question right here on the board. Okay, this is our very first question for the day. It is 4y squared minus 25. And we really want to factorize this expression. How do we go about it? Quickly, let me show you a quick reminder what the difference of two squared is all about. If I have a squared minus b squared, it's going to become a minus b times a plus b. I already have a video on the very basic of difference of two square. It's right here on the playlist. If you check the difference of two square on my video playlist, you're going to see the very first video I did on difference of two square. I think you should go watch that. But before you switch over to that channel, let us quickly finish this stuff. So with this understanding of difference of two square, that when you have a number squared minus another number squared, you can factorize it in this way: a minus b, a plus b without their square. So let us go about solving this problem. Now the very first thing you want to do is to make sure each of these terms are in square. And how do we go about that? You know, we can rewrite 25 in powers of 5, and we can write 4 in powers of 2. So in index form, 4 will become 2 to the power 2, and we have y squared already here. Then 25 will become 5 to the power 2. Yes. So by indices, I'm going to convert these two powers to become one power because they both have the same power. So I'm going to rewrite it as 2y all squared minus 5 squared. Okay? Now you can see we can now apply the idea of the difference of two squared. Now writing this as my a and writing this as my b will definitely become 2y minus 5 now times 2y plus 5. This is the answer to this question. We have successfully factorized this expression to become this. I believe this is clear. This is our question number 2. Now we want to factorize this expression here, this algebraic expression by difference of two square, by applying the knowledge of difference of two square. So the very first thing you want to do is to make sure you put all of these terms in squared. So you can see 81 can be written in powers of 2 as 9 to the power 2. So I can write 81 as 9 squared because 9 squared will give me 81. And of course, this guy is already in his good shape, so we have no issues with that. Now with this, we can apply the knowledge of difference of two squared, which is like my a and b. So I will write them with the terms without the square. So here becomes 9 minus y, and here becomes 9 plus y. This is the answer to our question number 2. So question number 3, we want to simplify or want to factorize this algebraic expression 300 minus 3s squared. Now the very first thing you want to do is to make sure they are all in square. So you can see 3 and 300 both have a common term. So if I factorize 3 out from 300, I'll have 100 minus, if I factorize 3 from 3s squared, I'll have x squared. Okay? As if to say 3 times 100 is 300, 3 times minus s squared is minus 3s squared. So we just factored out the 3 factor. Okay? Now you can see that this one is very easy now to put it in the form of a square. Okay? So let's go about putting it in the form of a square. So we have 3 into 10 to the power 2 minus x squared. Okay? 10 to the power 2 is same as 100, so we have no issues with that. Now with these guys in square, we can easily apply the knowledge of difference of two square, which will become 3 into, we have these guys like these guys. So we have 10 minus x and 10 plus x. This is the answer to question number 3. Question number 4. We want to factorize this algebraic expression on y cubed minus 25y. Of course, you can see that this is cube and we need something as square. So to make this easier, or to be creative in your thinking, what you want to do is to factorize this y from this expression so that we can have a square in our first time. So if I factor out y, I'm going to have y into y squared minus 25. As if to say y times y squared is y cubed, y times negative 25 is negative 25y. So we just factored out the y term. Now you can see that these guys can easily be put in the form of a square, and 25 can be written in powers of 5. So we have y into y squared minus 5 squared. Okay? Yeah, because 25 is still same as 5 squared. Now we can go about applying the idea of difference of 2 squared. So we have y into y minus 5 and y plus 5. This is the answer to question number 4. This is question number 5. And this is on real numbers, just on real numbers, okay? So we see no problem. We just need to apply the laws of the difference of 2 squared. This guy is in square, this guy is in square. Very easy to solve. So we have it to become 9 minus 98 times 99 plus 98, okay? Writing them in this format without their square, okay? So 99 minus 98 is simply 1, and 99 plus 98, 9 plus 8 is 17, 9 plus 9 is 18, plus 1 is 19. So 1 times 197 will give me 197. So this is the answer to question number 5. This is question number 6, and this algebraic expression is depending on 2 variables, which is the x and the y. Okay, no problem with this. Now the very first thing we want to do is to make sure they are all in squares before we can apply the idea of difference of 2 squared. So I can write 64 in square and I can write 100 in square, but this guy here and this guy here, I need to factor out x so that this guy can be in square, because we need to be creative in our solutions here. So I need to factor out x so that I can have x squared here, and I'm good to go. So if I factor out x, I will have x into 64x squared minus 100y squared. As if to say x times this will give me this, and the x times this will give me this. Now you can see that okay, it's not perfectly arranged, so let me go further to say this can be written as 64 can be written as 8 to the power 2, then x squared minus 100 10 to the power 2 y squared in close bracket. Now because they both have the same power, I can converge them to become one power because of the law of indices. So this can be written as 8x all squared minus 10y all squared. Okay, now they are all in square, so we can easily apply the law of the difference of 2 squared. So this guy becomes x into 8x minus 10y. Okay, writing them without the square, then times 8x plus 10y. Okay, so this is how it will look like, and this is the solution to question number 6. 2 more to go. This is question number 7, the second to the last question, and this one, you know, as the number increases, the question tends to increase in complexity. But I tell you, there is no issue with this question if you stick with me to the end of this work and to the end of this video. So the very first thing I want to do is to make sure they are all in squares. That's the very first thing I want to do. And now you can see that x4 and y4, there's no way I can factor out x4 and y4, but there's a creative way I can write down these powers of 4 in 2's, okay? So let's go about it. So I can write 49 as 7 to the power 2. I can write x to the power 4 as x squared, okay? Then all to the power 2. This is the same as x to the power 4 because 2 times 2 is still 4. But we just really need the square. Yeah, so minus 81, then minus 9 squared, then this guy will become y squared all to the power 2, as if to say 2 times 2 is 4. So there's no issue with that. We really want them, we just want them to be in squares. Yes. So by the law of indices, so I'm going to convert these two power to become one power. So I have 7x squared. Okay, that's this guy. Then the power becomes 1 all squared. Okay. Now you see this square is for both of them in this factor. So minus this will become 9 y squared. Then their square here, this 2 squared becomes this square here. Okay, so that is exactly what it will look like. Now you can see they both have squares, so we can apply the law of difference of 2 squared. So we have this guy 7x squared minus 9y squared. Now we go again, 7x squared plus 9y squared. I believe this is very easy for you to do. Okay, so let us go to the last example for today. Okay, viewers, this is the very last example for today's learning. Okay, so and you can see these guys are in powers of 6, no problem. We can still put them in powers of 2. Yes. Okay, like x to the power 6 can be written as x squared and 3. Sorry, x3 2 because we want the square to be outside. Okay, yeah, so 3 times 2 is still 6. Okay, so no issues with that. Okay, now I want to write 749 in square form, so I have 7 squared. Then this guy will become like this, x3 all squared. Then minus, I have 81 is 9 squared. Then I have y3 squared because 3 times 2 is still 6. No problem with that. Okay, now the next thing you want to do is to bring their squares together. Okay, so you don't get confused. So this guy becomes 7, that this 2 becomes this square. Okay, so I have 7s cubed, then minus these squares become the same, so I have 9y cubed all squared. Okay, so now they are in the square format and you can easily apply the knowledge of difference of 2 squared. So we definitely going to have 7x cubed minus 9y cubed. Then we go again, we have 7x cubed plus 9y cubed. Yes, this is exactly the final answer for today's question. Yes, I believe this video has added value to you in one way or the other. Really appreciate you for staying to this very end of the video. If you still have problems on difference of 2 squared, do well, chat me up on the comment section, or I will leave my contact link on the description box so you can maybe message me or text me, and I will try as much as I can to respond to you. Thanks for watching. Have a nice day. God bless you. Bye.